this is going over the solutions to our drawing conclusions. So we are going to be using some of our theorems that we've learned to draw the correct conclusion. We're going to be giving our definition in the if-then format. And so let's dive into number 1. So the first thing we're told is that line AB and line BC are perpendicular. Remember, this symbol means perpendicular. So the conclusion I can draw from that is that this angle that those two lines form is a right angle. So our conclusion is that angle ABC is a right angle. And the definition or theorem that supports this conclusion is that if two lines are perpendicular, and we can use our symbols for shorthand, are perpendicular, then they form a right angle. And again, I'm going to be using symbols for shorthand. So that was number 1. Number 2, we're told that angle DEF is complementary to angle HEF. So my conclusion there is that because these two angles are adjacent, they touch each other, and they form they are complementary. That means they add to 90 degrees. This means that my conclusion would be that angle DEH is also a right angle. And my theorem to support that would be that if two angles are complementary and adjacent, then they form a right angle. And again, I'm going to be using abbreviations and shorthand. All right, so the last one on this page, number 3, we're told angle WXZ is congruent to angle YXZ. So my conclusion there would be that this line XZ bisects the larger angle WXY because it's split into two smaller pieces. So segment XZ bisects angle WXY. And my theorem supporting that is, if a segment divides an angle into two congruent angles, then it bisects that angle. Okay. On to the next page. Number 4. Given that ray QS and ray QT trisect angle PQR. So remember, trisect means to split into 3 congruent parts. So that would mean that these 3 angles, smaller angles, are congruent. So our conclusion would be that angle PQT and SQT and SQR are all 3 congruent angles. And my theorem that would support that is, if 2 rays trisect an angle, then they divide the angle into 3 congruent angles. Divides it into 3 congruent angles. All right, number 5, we're told A and R, which are points on this segment, trisect segment CD. So A and R trisect segment CD. Now remember, the definition of trisect is it splits it into 3 equal pieces. So that would mean that CD was split here, here, and here. So my conclusion would be that segment CA, segment AR, and segment RD are all 3 congruent segments. And my definition that supports that would be that if 2 points trisect a segment, then they divide it into 3 congruent segments. Number 6, if E is the midpoint of AC, that's what we're given. E is the midpoint of AC. Now remember, midpoint is the middle point, so I can conclude that AC and EC are congruent segments. Sorry, AE and EC are congruent segments, because if a point is the midpoint, then it divides the segment into 2 congruent segments. Number 7, we're given this diagram. So remember, we can assume straight angles. So angle PQR is a straight angle, which means it adds to 180 degrees, and PQS and SQR add to that 180 degrees. So our conclusion here would be that angle PQS is supplementary to angle SQR, because if 2 angles form a straight angle, then they are supplementary. Number 8, we're told that line WZ bisects segment VY. So it bisects this segment. Now remember, the definition of bisect is that it splits it into 2 equal parts. So our conclusion would be that segment VZ is congruent to segment ZY, because if a line bisects a segment, then it divides it into 2 congruent segments. All right, again, we have another diagram on number 9, and we're told that line CG bisects BD. So again, this is very similar to number 8. CG has bisected BD, which means it's splitting it into 2 equal parts. So that means that, BF is congruent to segment FD, because this is the same thing as number 8. If a line bisects a segment, then it divides it into 2 congruent segments. Okay. Number 10. Last page. We're told that segment PA is perpendicular to segment AR. So our conclusion here would be that PAR is a right angle. And our theorem supporting that would be, if 2 segments are perpendicular, then they form a right angle. Number 11, we're told that angle AEN is congruent to angle GEN and is also congruent to GEL. So these 3 angles are congruent. So our conclusion there could be that this largest angle AEL has been trisected. So our conclusion would be that ray EN and ray EG trisect angle AEL. And our theorem to support that would be, if 2 rays divide an angle into 3 congruent angles, then they trisect the angle. Split it into 3 equal parts. And last but not least, number 12, we're told that PQS, this angle, is equal to 90 degrees. So in the long run, what we can conclude here, if PQS is is 90 degrees, that means that PQS is a right angle. And we can conclude that because if a measure of an angle is 90 degrees, then it's a right angle. All right, and that is our drawing conclusion note.